When you have a set of data, you want to see how spread out the data is, not only measuring the center of the data. So measures of dispersion is a type of calculation we're going to do to see how our data is spread, or maybe more relative to the mean. There are a couple of things we use to measure this dispersion. One of them is using the range, which is something you've done before, so it's the maximum minus the minimum. You also have the interquartile range, which is the third quartile minus the first quartile. And then you have the standard deviation as well. Now, the standard deviation by definition is the square root of the variance. So this is the variance, and the standard deviation is the square root of that. And we're going to go into detail on what that means. But basically what the standard deviation does, we usually, for convenience, we use standard deviation because it follows the same unit as your data. The standard deviation tells you how far away your data is from the mean. So it's much more helpful than the range and the interquartile range. So it really looks at the center of your data and then tells you how far your data is from the center. If you're using the variance, then the answer will be squared. So if your data is in centimeter, then the answer for the variance will be in centimeter squared. So that's why we take the square root of the variance to use standard deviation instead. So we're dealing with the same unit. Now, for range, it's quite easy to calculate. You take the maximum data minus the minimum data. For interquartile, you need to actually calculate the third quartile and first quartile. Now, what this quartile means is their values are divided into quarters. So the first one tells you that 25% of your data is below. The second one tells you that the second quartile tells you that you're splitting your data exactly in half, and the third one tells you that you have 75% of your data below. The IQR would be the difference between Q3 and Q1. So as a representation, usually we use the box and whisker plot. So if I have my data, this will be my Q1 and this will be my Q3. Usually 25% of my data is below my Q1 and 75% of my data is below Q3. Again, if you have like all of this data, then Q1 will be the first quarter and Q3 will be about here, putting in 75% of the data below. And we'll show an example on this. So how do you actually calculate it? Well, before you start, you need to identify what is your N, which is the total number of data sets. So for example, you have 50 data sets or something, or data values. So to find the lower quartile, you do n plus 1 over 4. To find the median, it's n plus 1 over 2. And to find the upper quartile, it's n plus 1 over 4. But the n plus 1 is multiplied by 3. If you need the p percentile, so the 4%, for example, then you'll do n plus 1 multiplied by 4 over 100. Now, be careful that this only gives you the position. So it only tells you, for example, if your answer was 4, then it tells you that it's the fourth number in the order that you've done your data, which makes sense because if you're doing n plus 1 over 2, it's going to tell you where half of the data is. If you want the value of the quartile, you'll have to actually count where the fourth data is. So through an example, if I have this data set, I'm going to put them in ascending order, so I did that. I'm going to label the position that's going to be helpful. So 1, 2, 3, 4, 5 until 12. So I know my n is equal to 12. So n in this case is equal to 12. I have 12 data sets. And now I can calculate the dispersion values. So the range is going to be the biggest value minus the smallest value, so that's 143. Now, I don't get enough information from the range, so maybe interquartile range is going to help. So the interquartile range, I'm going to do 12 plus 1 times 3 over 4. I get 9.75. Now, this is the position. Be careful. So what this tells you is that your data is between the 9th and the 10th position. Okay, so it means it's between 81 and 100. So you're going to take the average of your two numbers. And then similarly for Q1, I'm going to do 12 plus 4, that's 3.25. So 3.25, it means my data is going to be between 3 and 4. So between 3 and 4. So it's 9 and 16. So I'm going to take the average of them, which is 12.5. So my Q1 is not 3.25. It's actually 12.5. And my Q3 is not 9.75. It's actually 90.5. So I'm going to subtract them to get the interquartile range, which is 78. Now, what does it look like? So notice how we've identified where the quartiles are. So you can notice that the Q1, I have 12 data sets. So it's actually split my data into 4 quarters. So my Q1, I can see 25% of my data is below it. My Q3, I can see that 75% of my data is below it. And in Q2, I can see half of my data is below, half of my data is above. So that's a good visualization.